Welcome to Pavithra Laptop Care. Today we are going to discuss about pull up and pull down resistors. So first question, what is pull up resistor? Why these are used in motherboard? What are the uses of these resistors? So we will find out the answer for this in a schematic or in this particular chapter. Before we start, we come to know some basic points. Those are about logic levels. See, logic levels in the sense, so everyone knows logic circuits. That's called, it's a digital circuit. Maybe it's a controller I/O or processor or any other digital circuits can understand only 0 or 1. That's called logic level. It's called machine level language. It won't understand any other languages except 0 and 1. The voltage range that determines whether a digital device interprets an input or output as a 0 or 1 is known as the logic level. The voltage range that determines whether a digital device interprets an input or output as a 0 or 1 is known as the logic level. Here there are two examples we have taken. So one is 5 volts logic families and second one is 3.3 volts logic family. Here it indicates in 5 volts 0 to 1.5 volts is considered as a low, logic level low. 1.6 to 2.9 volts will be considered as it's a floating and no result at all. And 3 volts to 5 volts will be considering as high, logic high, it means 1. In 3.3 volts level, 0 to 0.8 volts will be considered it as low, means it's a logic level 0. 0.9 to 1.9 volts will be considered as floating, there will be no result. 2 volts to 3.3 volts will be considered as logic high, that means 1. There are some logic families examples. One is TTL, DTL, CMOS and ECL and more. Just we will consider 3.3 volts logic families. Here already I explained 0 to 0.8 will be considered as 0 or logic level low, and 0.19 to 1.9 will be considered as a floating, there will be no result, and 2 to 3.3 volts will be considered as a logic level high, that means 1. In this, very most important thing is we have to consider Ohm's law. See, here is the Ohm's law triangular. V means it's a voltage, I current or resistor. Voltage is equal to I into R. When we multiply current and resistor, we will get voltage, and I is equal to V by R. Similarly, R is equal to V by I. Okay, this is called Ohm's law. It's very important to apply in this particular logic circuit to know the current value or voltage value or resistance value. Let's begin. See, this is the most important image. Here you are seeing it's a switch. Okay. If you apply the switch, sometimes it will get burned, right? See the spark, due to the spark it may be burned or it may be damage the circuit. Okay, this is the logic point to know the logic level circuits. As per the schematic, 2.2K okay, resistor and 3.3 volts voltage has given. Okay, and what will be the current as per the Ohm's law? Let us calculate what will be the current. See, I is equal to, as per the Ohm's law, I is equal to V by R. V by R. We know the voltage, that is 3.3 volts, and resistor is 2.2 volts. sorry, 2.2k. It means 2200 ohms. Okay. Now the I is, let me calculate, V 3.3 volts divided by 2200 ohms is equal to 0.0015 amps. Okay. See, if you want resistor value, that also we can consider, considering as a Ohm's law we can calculate. Okay. Here R is equal to V by I. So here V, we know it's 3.3 volts, and I just now we calculated it's 0.0015 amps, and R will be here 3.3 divided by 0.0015, it's 2200, means 2.2k resistor. Okay, like this we have to calculate as per the Ohm's law. Calculate the resistor or current or voltage in a circuit. Okay, now one thing I'll tell you, in this particular schematic it has gone to page number 40. We will find out it's a 40 page number. That is IO. It's integrated circuit. I mean, it's a controller IC. See, this is an IC. So you know very well, all ICs are working using logic. All ICs are working using logic levels. That is 0 or 1. Here I am going to explain why the pull-up resistor has given here this particular circuit. See, logic gates will be worked through logic levels, that is 0 and 1. All controller IC or components can understand logic level, that is 0 and 1 language. Here let's take a OR gate. Okay, this is the OR gate. See, here 1 and 2 are the common point, and here one switch, it means it's in open condition, and there will be no meaning, because as I told, logic gates should give some commands, zeros and ones, that only it will understand. If you connect the switch or connect the supply, there will be no result. Okay, it's a floating stage. See, if you connect the circuit, then also due to floating condition there will be no result. Okay, this is the first condition. Second, in second image I have written here, see, for these two inputs I have given 3.3 volts through a resistor to the each connector. Okay, see, here it's there is no connection, it's an open condition. In this case 3.3 volts VCC goes through 2.2k resistor, and it will be some amount of around 3.3 or 3.2 or 3.1, whatever it may be, that will be connected to this particular pins of the logic gate OR. It means here, because of this open condition, so voltage will pass through this particular connectors, then it will become a high, means here we can get 3.2 volts as it is. Here also high, here also high. As per the logic gate condition, 1 is equal to 1 is equal to 1. 1 or 1 is equal to 1. Okay, logic high will be 1. Here, if we close the circuit, the 3.3 volts passes through the resistor, and some loss of electrons will be there because of this 2.2k resistors, and easily this flow of electrons goes to the ground. Okay, This is called logic level low. See, in case if you won't apply the resistor here, so what will happen? Here voltage will pass suddenly, and when this circuit close, immediately the spike, the highest amount of flow of electrons will causes the circuit damage. Okay, this is the main reason we are using the resistor here. See, once again I will tell you here 3.3 volts directly comes across to the particular connector, and once we close the switch, so all of a sudden you know the switch condition, any of switch will close, suddenly a spike will generate. Okay, that may damage the circuit or logic level circuits, logic gates. Okay, to avoid the damage, pull down or pull up resistors are used. This is the main condition here using the pull up resistors.